दिख रहा है? ठीक है, तो पहले वाले में कोई डाउट है, इसके पहले कुछ में, या एक बार फिर से कवर कर लें?
कर लेते हैं, कुछ है नहीं तो।
अच्छा, ठीक है, एक बार ओवरव्यू ले लेते हैं, क्योंकि आज तो स्ट्रक्चर हो जाएगा ख़त्म, उसके बाद फिर कोड्स पे आ जाएंगे। तो चल छोड़ो, वो तो बाद में देख लियो, एक बार बाद में फिर से देख लियो, जब कभी देखेगा तो देख लियो। कहीं से शुरू कर देते हैं। ठीक है, तो so basically there are flavors of Linux. So flavor means types of Linux. So basically there is one thing that everyone just takes the kernel, and on top of the kernel just adds multiple things, so that like in Ubuntu the theme is different or wallpaper is different. In Red Hat the softwares are different, and in Debian the package manager is different, and in Arch Linux it is completely based on hacking and all that stuff. So basically what it is they all use the small basic component that is kernel, and on top of that everyone just installs the software as per their user base. So like Ubuntu wants to prepare the Linux for general purpose user like developers or coders. So they just did like simple themes, simple softwares for education and for presentation, Word presentation library. So they have added this in Ubuntu. In Red Hat, so Red Hat is for networking. So it is used in servers and major companies like Airtel and all that. So Red Hat is used in that level. So there are a server that is given access to all the employees present in the office. So basically, Red Hat is like one system is running at a particular area in a server room where there are 1,000 PC running, and every 1,000 PC is given access to all the persons or employee using in that area. So let's suppose in Airtel, they are not providing each individual employee a new system. What they are doing is they are just keeping all the CPUs of the employees in a room, and they just lock that room so that no one can go or enter that area. So what the user has to do is all the systems are there in one room, all the CPUs are in one room, and the employees are just given their monitor. So monitor, keyboard, mouse, these three things are provided to every employee present in the room. So basically what it means is there is a bunch of area where all the CPUs and processing power and heating is going on, and all the employees are just sitting without the ACs or without any other stuff. So they don't need the same environment as CPU. So as we know that CPU becomes hot when we use it for long time, but in case of server rooms, the server rooms is attached with AC. So AC runs 24 into 7 times there, and all the systems get cooled frequently. So that is the flavors of Linux. So every person, every employer, every company just takes the Linux kernel and develops and combine it as per their requirement, and then just give it to the user. So basically, as I told you that Ubuntu is for general purpose and anyone can use it. Even a small children who is just like doing the homework, he can use Ubuntu for web surfing and all, and it is very fast as compared to Windows. So the main feature of Linux is like if you just purchase a new PC of Linux, so even after 20 years, the system will run in the same way as it was running initially. But as you can see, like if you purchased a Windows system, and even after 1 2 years, the system just slows down. due to like temporary files are there, the memory is slow down, and many other factors make Windows slow, but Linux never gets slowed down. So it runs consistently at the same power. And then again, that Red Hat is for networking and big enterprises business. So where 20,000, 30,000 developers are working at the same place, they are just using Red Hat for that, to make the deployment easier. Then Debian is for like very lightweight type of Linux. So all the fancy things in the Linux are removed, and it is just treated for simple things. So like in Raspberry Pi, the Raspberry Pi is very small, and in that the CPU is very small. And as compared to our CPU, our computer CPU, the Raspberry Pi is very small machine and is having all the same components as the CPU itself. But since the size is very small and the storage is very low, then Debian is prepared for that only. So all the things are removed, and just to make it work on a lower end processors, Debian is used. So, and then Arc Linux. So those who were working in networking and hacking, ethical hacking, and in some government organization who are tracking the persons. So as you can see in some movies, the tasks that is encrypting the server, decrypting the server, and all that. So that part is done with Arc Linux. So yeah, that is why everyone prefers Linux, because in Ubuntu the software used for hacking is not present there, and in Red Hat, no PowerPoint presentation things or the softwares for calculation and calculator. All these things are not present here. In Debian, the bright, colorful themes and screensavers, all that is not present in Debian. And then in Arch Linux, so in Arch Linux, no one can use the things that are deployed in Red Hat. So that is why everyone prefers Linux, because it provides specific things to every specific user. And again, the basic component of whole Linux community or whole Linux is just a kernel. So on top of kernel, everything is built on. So just I have explained you in the last lecture that take it as an example of pizza bread, and on top of pizza bread we are distributing things that are differently for each person. So if someone wants non-veg pizza, and then someone wants veg pizza, and someone wants something else, so they can be added later on as per the requirement of the person. Similarly, in Windows, there are Windows Server 2003, 2008, 12, and latest 2016, 20, all that. Then Vista, Windows 7 XP, and Windows 10. So these are the variants of Windows, flavors of Windows. But also you can see that Windows 7 Pro, Windows 7 Home, Windows 7 Multi-User. So all things are there in Windows also. So yeah, that's it. So, like, let's move on to the architecture of Linux, because it is the most important thing that is asked in any technical interview. So, it is little boring, but yeah, it is most important thing so that we can start with scripting. So, basically, how architecture look like. So, basically, there are two parts in the whole Linux system. So, in the Linux system, there are two parts. So, the first part is called kernel space, and the other part is called user space. So let me switch to a pointer. Yeah, so there is a part in user space and there is a part in kernel space. So why these parts are different? So basically, as I told you that there are multiple flavors, so let's just take two Linux flavors. So the first one is for hacking, let's suppose, and second one is for business. So in business, let's suppose Airtel. So we are creating two Linux. That is one for hacking system, hacking organization, and another is for businesses like Airtel and networking company. So they just want the satellites and all that stuff into their system, but the hacking authorities don't want that. They just want password breaking algorithm, and so there are multiple algorithms that are used for finding the password and hacking the Facebook accounts of users or other stuff. So basically, there are two parts of that. So what it means is, in the kernel part, in the kernel space, the things present in the kernel space are specific for the user. Yeah. So basically, a complete Linux is based on two things: kernel and user space. So basically, like, the kernel is same for every Linux. So if you just break into any system, the whole directory, and like, yeah, just for example, like if you purchase a Windows system, a Windows laptop, then you will at any system you will find that in C drive the Windows is installed, the D drive is empty, and it is used for R purposes. And in some rare cases, the system may have recovery drives also. So that is E and F, maybe in most cases. So all the Windows are installed in C drive, even if it is Windows 7, Windows 10, Windows 98 or 97. Any window version of Windows will have Windows in C drive only. Basically, it is not installed in C drive. It is like coded. Windows is coded like that, like in which drive the window is there. Just rename it as C. So that is the Microsoft thing. So basically, kernel space and user space. So kernel space remains constant for every flavor, every version of Linux, and user space is specific for every particular user. So if anyone asks you about like what what is Linux, so we can always say that Linux is a combination of kernel space and user space, in which kernel space is the base of everything, base of every Linux system, and user space is specific to every user. It is based on the requirement of every user. So basically, there are two parts in a Linux: kernel and user space. So that is so in the hardware platform. So let's just get a little more into depth of that. So user space and kernel space. Let's study kernel space first. So kernel space, there is hardware platform. So hardware platform means like mouse, keyboard, and CPU chip, motherboard, and hard disk. All these stuff are in hardware platform. Then there is architecture dependent kernel code. So based on architecture, the kernel code is dependent on. So what it means is, if your system is uh, 64-bit, so the kernel will be using 64-bit code. And if the system is 84, like 86, x86 or 32-bit, so the kernel will definitely switch to that code, that part of code. So that is kernel code. And then there is kernel, and then there is system call interface. So system call interface is when we boot up the computer and we start something else, some application or that. So that application is uh, given to the kernel via system call interface. And then in user space, there is like GNU-C library, that is multiple software that is defined for a particular user. So there can be Python library or C library, Java library, and all these libraries are user specific. So if the user is a developer or coder, then all the libraries will be there in user space. So when a user just wants an application to run, so basically he first purchases a platform, that is hardware platform. And talking about a small thing like 86, 86 or 32 and 64-bit. So 32,
TNU full form क्या है?
क्या
TNU full form.
GNU बाद में देख लियो एक बार. GNU एक मतलब टाइप है लिनक्स का, वही है, वो एक बार बाद में देख लियो. मतलब हर चीज़ की फुल फॉर्म नहीं होती. GNU एक पूरी टीम है, उसका नाम है, जिन लोगों ने ये चीज़ों के बारे में बनाया. जैसे सी लाइब्रेरी के बारे में किसी ने बताया, तो GNU है.
TNU not Unix.
हम्म. सो GNU बस नॉट यूनिक्स, मतलब एक किसी ने नया वर्जन या वेरिएंट बनाया जिसका नाम GNU नॉट यूनिक्स रख दिया और उसको यूज़ कर रहे हैं लोग। तो ये इसके दो पार्ट हैं टोटल। तो अगर किसी ने हार्डवेयर लिया बेसिकली, हाँ, सो आई वाज टॉकिंग अबाउट द डिफरेंस बिटवीन 32 and 64 bit. So we can generally see that every software is based on two things. So you choose the 64-bit version or 32-bit version. So what is the difference between those? So basically, if the user is having old hardware, then his system will be supporting 32-bit. And by old, I mean literally like 2002, 2003, and 2005. If you are having a system from that time period, then definitely you are having a 32-bit system. And after that, all the systems were converted to 64-bit. So what is the difference between 64 and 32-bit system? Let me just explain you first, so it will be easier to understand further. Yeah, so the difference between that is, let's suppose this is a bit and this is 64-bit. So let's suppose this is 32-bit, this is 64-bit. And what is the difference between that is, so let's suppose if there is a user A, he wants to add number A and B. So this number is having, let's suppose 128 bits. This user is having 128 bits number, and he wants to add it with another number that is again 128 bits. Okay. So when we are just using this 128-bit number for inference or for calculation, so there is two type of calculators. So there is one calculator. It, this is 32-bit, or yeah, there is different calculator that is 64-bit. So in 32-bit, 32 is also called as 86. So these both are same, and this is 64-bit. So what it means is, if you have downloaded the app that is x86 or 32-bit, then 128 divided by 4. So the number will be divided into four parts and then given to the computer. So it will take four cycles to give the result. And in 64-bit and in 64-bit application, it will take just two cycles. So by cycle, what I mean is, the whole number will be broken into four parts and then will be fed into the system. First, first 32 bits, then second 32 bit, then third 32 bit, and then fourth 32 bit, and then all the data will be given and processed. The result will come after four cycles. So that is the difference between 32 and 64. So basically, when you are downloading an application, if you see 64-bit application, what that means is, if you are doing a task that is like calculation in a Excel sheet or something else, so the whole system will be splitted into less parts and the whole program or whole process will be done in less cycles. But if you are having a 32-bit program, then the program will take twice the time that is taken by a 64-bit system. So that is the difference between 32 and 64. And also there is one important thing. So if you are having a 64-bit PC, like as you have told, like are having uh, i5 with 4 GB RAM, so that's basically you are having 64-bit PC, but you are installing 32-bit program. You are installing 32-bit program on that. So this 32 64 will never work because the program is 32-bit only. So to best utilize your 64-bit processor, you have to use 64-bit programs. So every time you download a new program, try to find the version which is having 64 bits or 64x, so that your processor can work in its best capacity. If you just use the 32-bit program, then it will take 4 cycles even if you are having 64-bit processor, because the software will break the whole number into 4 parts and then will send it 4 times. And if you download the 64-bit, then it will work flawlessly. And as you can directly infer with that, so what you can infer with that is, if you are having 32-bit PC, running a 32-bit program will take 4 cycles, which is true. If you are running 64-bit, how many cycles it will take? Yeah, again an interview question.
Two seconds.
No, wrong answer, rejected. This will not run. 32 on a 32-bit system, 64-bit programs can never run and will never run, because in a 32-bit the size is this much, and we are entering 64 numbers into that, and definitely it will not work in any case. So yeah, if you try to install 64-bit software on a 32-bit processor or 32-bit Windows, then it will say error, 64-bit program can't be installed on your system. So that is very tricky question. Everyone just say it as 2 cycle, which is really wrong, because the program will never work on that system because it is not having enough memory. So the higher can run the lower programs, but the lower system cannot run the higher program. Okay.
Okay.
Okay, so यहाँ पे, सो ठीक है. सो लिनक्स का बेसिक आर्किटेक्चर इज यूजर एप्लीकेशन, यूजर स्पेस, एंड देन कर्नल स्पेस. सो कर्नल स्पेस is taking the hardware and the software interconnection, and the user space is specific as to every user. So just again, think it as pizza, and this is topping, and the whole thing is a pizza for us. Okay. So when Linux is running in main memory, it is divided into 2 parts: user space and kernel space. User applications are running in user space, and kernel is running in kernel space, which I have told you. So
नोट करूंगे.
I will share the presentation, but हाँ नोट कर ले.
आर्किटेक्चर तो बना लिया मैंने.
अगर नोट करना है तो ये चीज़ें नोट कर ले, बिकॉज ये अपने भाषा में लिख लेगा तो सही रहेगा.
हाँ लिख लिया मैंने वो पहले आर्किटेक्चर.
ठीक है, तो द सिस्टम लाइब्रेरीज लाइक glibc, like in this case glibc, gnu c library, defines a standard set of functions through which application interact with the kernel and implement much of the operating system functionality that does not need full privilege of kernel code. So basically, the libraries that are present in the user system are defined with specific functions, so that, like, if we are adding two numbers, that is, we are making a calculator app. We are just making a simple calculator app that takes input from user, two numbers, and then print the result. So definitely your calculator app will not require your location, your phone number, your email address, your Aadhaar card, your PAN card details. So that thing is not required by calculator. So that is the thing which is required by system libraries. So system libraries will define which application should interact with internal, and the level it is required to access the system. So the calculator app will not require the the admin privileges. So the calculator application does not need to know the whole system password and your name and your email ID, and all these stuffs are not required by that calculator app. So when every time you install a particular app, it is asking for permission that you want to share this or not. And if we say yes, then all the things will be shared to the system. And if not, then the system will not get access to that system software. So that is the basic thing of system libraries. So system libraries control the privilege given to every software for the kernel. Because there is a reason for this, like why we need not to give access to all the system to that system. So let's suppose you are using a calculator app and you just downloaded a 64-bit calculator app because your system is latest Windows 10 and having 4 GB RAM, and it is 64-bit. So when you are adding two numbers, 2 plus 3, what the program does is, in your system, it deletes the RAM. It is not possible, but let's suppose it deletes some part of your RAM. So basically, if you are listening a song and the calculator app, just after you clicking to 2 plus 2, it is closing all the functions that are present in the app. Like it is closing your song, closing your YouTube video, your browser, and your video conferencing, and all the apps are closed by that calculator only. So that is like, we don't want that functionality to happen, because that calculator is just to take two numbers from us and give the result, and not to close all the things that are present in the phone, in the phone or the system. So that's why we need to limit the privileges of a system app to a kernel, because kernel is the main thing of the whole system. So basically, if I hack into your phone and I just shut down your kernel, then by any means you will not be able to reboot your phone. Even that functionality of starting your phone is lost. You will not be able to ever start the phone until I will release that again. So that is the basic main component of the whole Linux system, and it requires privileges for every system profile and every action that we are performing. So just for like टाइम से पहले एक बता देता हूँ. So just for that, sudo is the thing that is required in Linux for executing every application or everything that is having privileges of Linux. So basically, if you are installing NVIDIA drivers, then you have to write sudo install NVIDIA drivers. Before sudo, if you try that without sudo, then the whole system will never allow the NVIDIA driver to install and update your driver. So that is thing in this Linux. So we have to write sudo install then NVIDIA. If I just write install NVIDIA, it will say permission denied. I am not able to perform this function. So yeah, that's it. Then there is basic introduction to the kernel. So kernel is a resource manager where the resource being managed is process, memory, hardware, device. So as I told you, kernel is the layer between software that you are using and the hardware that is with you. So basically, manages all the things that are processes, memory, hardware, devices. So this is the history of kernel, and 2.60.0 is the latest one at December 2003, and it is increasing at an exponential rate, and the version is implementing and developing very fast.
एक सेकंड बैक करिए.
Done. Okay, so kernel is fine, but what is the difference between Windows and Linux? It is important for us to know the difference between those, because from the early age we are using Windows and now we are shifting to Linux. So we should know that what is the difference, what is the new thing that we have to learn Linux, and what is different in Windows. So that is the basic thing. Monolithic kernel is Linux and microkernel is Windows. So no need to get into depths for it. So just it is monolithic kernel, that is Linux kernel, and microkernel, that is Windows, and this one.
Done.
Hmm. So can you guess which one of that is monolithic and which one is microkernel? Just put a guess, small guess. Hello.
Ah,
Which one is monolithic? Which one is micro?
micro is right side.
Right side. This one. No. This one is monolithic,
हाँ यही तो बोला यार.
and
Right
this
side.
one is.
Yeah, this one is right side. I told you.
Oh, okay. So, just let's just see what is the difference between both. So we will know the difference between Linux and Windows. So basically, in Linux, there is VFS, just ignore it, IPC file system, scheduler, and device driver and dispatcher, and then comes the hardware. So in kernel of Linux, so many things are present in the kernel layer only, and in the microkernel part, that is this one, that is the kernel part that is interacting with hardware and this softwares that we are using. So in Linux, all the drivers are installed in the kernel part only, but in this one, the drivers and Unix server and application, all these things are installed in on top of the kernel. So that is the difference between Windows and Linux. So basically, the main thing is that if we are having access to kernel, we can do all these tasks easily while we are on Linux. But if we are having access to kernel, we are not able to do all these tasks because everything is accessible on top of kernel in Windows. But now, since this one was a much better approach, the Windows are just shifting towards this one. So Windows are also shifting towards this monolithic kernel. So this is monolithic kernel and this is microkernel. So microkernel is small kernel, and the user mode is top layer, then hardware, then kernel, then user mode. So as we have studied about this user space and kernel space, so kernel space in Windows is very low and kernel space in Linux is very high, very large. Everything is almost present in kernel of Windows, but in Linux, in Windows, everything is at the user end, user mode. Okay, so there is a joke. What are cloud made of? So this person is, I guess, a DevOps engineer. So DevOps are the person who are using and managing Linux and servers and all that. So
Yeah.
there is a specific category of developers, DevOps, developers dash operations. So these are managing the servers, Linux, and all the stuff that is Linux based, not Python, not C++, not coding based, but developer based. So DevOps are doing that thing. So this person is a DevOps, and he just told him that cloud servers are made of cloud Linux servers. Okay. So now features of kernel Linux versus Unix. So this is again an important thing. So so the first point is dynamic loading of kernel module. So kernel is loaded dynamically. Preemptive. Whenever we start a new process, the all the other processes are emptied automatically as per the system requirements. So it is preemptive. Before starting a new process, all the previously running process are emptied as per the requirement. Then symmetric multiprocessor support. Just learn this. Multiprocessing is supported by this Linux kernel and it is symmetric in nature. Another one is asymmetric, which is not good for system because uh, just just for example, as I told you, like if you have a bigger 64-bit number, If you have symmetric process, then you can just break it into two and send the two parts in symmetric manner. But if you are having not symmetric or asymmetric one, then this one will go first and this one will be uh, given to the system later, which is which makes it slow. Because definitely if you just have a 64-bit number and you just split it into two and just send the whole two numbers into the system and get the result, it will require less time. And in this case you send this one, and then when acknowledgement comes you send the second one, and then third one, then fourth one. So that is taking more time. So symmetric multiprocessor support. And Linux does not differentiate between thread and processes. So in Windows, like just okay. So I will show you later. So basically, this is an important thing. Linux does not differentiate between thread and normal processes. And the main thing, the best thing for Linux, why it is used for servers, is this word. So Linux provide an object-oriented device model with device classes, hot pluggable events, and user space device file system, which is known as sysfs. So what do we mean by hot pluggable? So why hot pluggable? Like uh, why the Linux is having hot pluggable, and why we have not learned about this in Windows? Okay, so let me just tell you that. So basically, in Windows, when you have to install any software, like let's just take an example. Let's create Windows here. So it's Windows. It's a name it's readable, I guess. So it's Windows, and when we have a software, so let's suppose we have to install a software called GTA. We have to install that on Windows. So we install that software. We copy first, then we install it, and then restart, and then we are able to play this. Okay, but in Linux, let's just install GT in Linux. It is not possible to install these games in Linux because of the reason I told you earlier. The Linux are having different file format. Linux are having .rpm and Windows are having exe format. So the game will not run directly in Linux. Let's just suppose it is working in Windows. So what we will do is we will copy it, install it, and run it. Any difference?
Restart Angular.
Hmm. So Linux provides the best thing possible ever. That is, we don't need to restart the program, restart the whole system after installing anything. So we can just install anything on a running system, and then we can get that installed and can directly run that without restarting it. But if we have to install anything in Windows, we have to install the drivers, restart it, because all the I will tell you the reason later. But yeah, Windows, we have to restart the system again, and then the drivers will be present in that system. So, 1 minute. Okay, so we were like Windows, we have to restart the whole software for again, but in Linux, we don't need to restart the system again. So that is the reason why we are preferring Linux on servers and high-end computing machines or supercomputers and all that, and we are not using these things in Windows. Definitely, you can see that in your phone also. In your phone, whenever you install a new application, you are not restarting the whole system again. Whenever you are installing or uninstalling an app, you don't need to restart your system. You never restart your system after installing an application. If you just install Swiggy, you don't need to restart your phone again so that the Swiggy will be installed in next stage, and then you try and experiment that Swiggy app, and then you find okay, it's not working well. It is not good. Let me install Zomato. So you click on uninstall, and then you have to again restart the system again, and then you have to install Zomato, then restart again, and then try Zomato. But in Android or in Linux case, we don't need to do that. We just install it, delete it, install a new thing, delete a new thing. So that is the best thing in Linux, due to which it is used for every important or every major thing. So this thing is called hot pluggable. And by hot pluggable, I also mean that if you have a driver, like if you have a graphic card and you want to install it on your system, graphic card in on your system. In Linux, what you have to do is just take the graphic card as a pen drive and plug it in your system. It will run from that point onwards without restarting the system, without changing anything, without installing any driver. It will directly run without any restart. But in Windows, if something crashes, you have to restart your system again, and after that. So that is the difference between hot pluggable and why Linux is having hot pluggable item. So the reason for this is very simple, very basic. The reason is present here. In this, Linux is having everything in its kernel, but in Windows, everything is in the user mode. So if any new thing or new application is installed in the system, then we have to restart the system so that all these things, the device driver, the file server, and Unix server, and all these things restart again and take the new application into their system. But in this case, the kernel just updates that thing and makes it available for us. Okay, so basically, when we start our Windows system, all the drivers that are present in it are loaded at the time of booting or rebooting. But in Linux, it doesn't happen in that case. All the drivers are updating continuously in that system. So that is the difference between Linux and Windows. So this thing is very important. Preemptive, then dynamic loading of kernel module. Like I have told you, everything, the application, the drivers, and all these things are present in kernel, and it is loaded dynamically. It is loaded again and again automatically. But in Windows, once we start the computer, everything loads at that time. After the computer starts, nothing can be loaded again. So that is the main difference between Windows and Linux. And yeah, so hot pluggable events and user space devices. Any doubt in that?
No.
Okay. So threads. Let me just tell you about threads. Magnifier. Okay. Yeah. So is it visible? Like cores are 2 and logical processes are 4. What that means is, so basically my system is having two cores, and the logical processes that are present in it is 4. So it's just virtual cores. So that Like if my application is running, it splits the whole thing into four parts and then sends that to two cores only. Let's not get into that much, but it's just to show that there are virtual cores, that is four, but the physical cores are two. So if you just open my system, you will definitely see that there are just two cores, not four. But while operating the system softwares, we get four cores. So that is the difference between this one. So, and in that you can see the hard disk usage and CPU usage and all that stuff. And so the threads and processes are there, which we will talk later on. So that is the threads. Okay. So basically, in this slide, you learned about that kernel version. So kernel releases 0.11, 1.0.0, 1.2.0, and later on. So how to read the kernel version? Okay, so that is an important thing here. So Linux kernel currently consists of four numbers: A, B, C, and D. The A number denotes the kernel version. It is changed least frequently, so only a major change in the code and concept of kernel occurs. Then B is the number denotes the major revision of that kernel. This is major revision of kernel. This is the kernel version. And C indicates minor revision. Okay. And minor fixes are handled by the number D. So what that means is, if my kernel is 2.3.4.5, so after a small minor change, it will get converted to 6, 7, and 8. But the main kernel version will be 2 for all these 2.3.4.8. This one is the minor revision. This is a major revision. When something major happens in the code, that is this. And this one is kernel version. So there is an analogy that all the developers use. So if the if B is even, then kernel is stable, else it is unstable. So if it is 3, then it is unstable. Unstable means a stable version will be released later on. So by stable and unstable, what we really mean about it is, if we are creating a system for someone, if we are installing something for someone, we try not to prefer this odd numbers one. We try to install 2.2. That that is true that it is less updated, but that is again also true that this is the most stable version. So his computer will not stop functioning if any error comes, because less errors are there in 2.2. Else we can wait for 2.4 until it comes, but 2.3 is the unstable version. So let me just go to the Ubuntu side. So Ubuntu is having all the uh, versions of Linux present here. It is not following the two ABCD architecture of kernel, but definitely you will be getting a chance to see the stable and unstable version. So we need download, and in download we need Ubuntu desktop, alternative downloads, alternate downloads, and past releases. So I am just getting the list of all the past releases. So you can see that Ubuntu 20.04. So 04 is even, that is, it is a stable version. If I want to suggest you to download this on your PC, you can just download this. Ubuntu 16.4, you can also download this, it is stable one. Ubuntu 18.04, again it is a stable version. So there is LTS thing present in here, like you can see that LTS, this one is also LTS. So what it means by LTS is long term support version. So if you are installing it on someone PC, if you are installing on your home PC, then Maybe the new features are not present in it, but it will be stable. It will not stop the other day. Like if you just start a program and the next day you check that again, it will be stopped or deleted. That is not possible in LTS, because LTS is the tested versions from all the community and all. So when they will approve that thing, they release it as a LTS. Okay.
Hmm.
So there is different thing like Bionic and desktop images for all, and 18.0.5. So 8.5 is the latest. So if something new comes in that system, they will release zero point 0.6. After checking that, they will release zero point 0.5, but zero point 0.5 is not stable. So they will make more changes. And after making the changes, they will release zero point 0.6. So 18.06 will be the uh, stable version. Okay. So that is that. Then there is block diagram of Linux kernel. So it is more expanded version of that part in the bottom layer. So kernel space. So initially in Linux there were two things: kernel space and user space. In kernel space, this is what present in the kernel space. So architecture, then device drivers, memory management used for controlling RAM and other stuff. The network stack, it is used for uh, taking care of Wi-Fi and Ethernet cable and internet speed and all that thing. Virtual file system, copy paste things are managed by virtual file system. Then process management, again it is choosing which information to keep, which information to delete, and which processes are to be closed. So that is managed by process management. So basically, if you are playing a game on your system, so like you just launched PUBG in your phone, and there is calculator, Zomato, Swiggy, and all other things running on. So the process management thing will delete or kill all other processes and will give all the system resources to the current running app, that is PUBG. Then system call interface, it is the like interrupt of that whole system. So we can close the app and delete that app or whatever we want to do with that app. So that is by system call interface. Okay, now processing block. So processing block, process is a program in execution. So whenever a program is executed, it is known as process. The process is represented in OS by process control block. So let's just suppose it as your game. So you just started your game, and there are multiple of things that are present in this process block. Pointer, process state, is it running or it is stopped? Then process number, out of 20 processes number, which one it is? Then program counter, uh, done in already MPMC. Then registers, then memory limit, and list of open files. So these are the processing structure. We need not to get into depth for it, but it is just for like architecture, then device driver, network stack, virtual file system, process and memory, then system call interface. Okay, so this is a little important thing again, because I have just find out all the important things that are being asked in the interview and that are common, and I just drop them into this slide. So all these things are present in this slide are important. So Linux kernel, how it understands our task. So we want to a task to be executed and how it will execute that. So Linux kernel stores the list of processes in a circular double linked list. So take it as a linked list. So the first task that is running, it will contain the next address, and the next one will contain the other next, and the next one will contain another next. The previous will contain the previous function, previous program, and then this one previous, and again the previous one. And in the final thing, the next one will be containing the first one, and the previous one will containing the previous one, right? So its previous is containing the last. So the last is contained in this previous one. So what it means is all the tasks that are need to be processed are in data structure format. So this is the first application that we created. Like let's just suppose no application was created at that point. So it is a starting point. Then we open terminal or calculator. So after opening the calculator, the next is this and previous is this. And if you want to switch on previous process, then it is this blank one. If we want to switch to next process, then this is this. Then let's
Got
move
it.
on to different thing. Open another app that is, this is calculator, this is music, this is movie. I don't know why a person will watch movie and play music in his system. I don't know, but let's suppose he's doing that.
He's
So
ginger.
it is recorded. Okay. So so calculator, then music, then movie. So if someone is not running anything, then this is the primary thing that is present. Then he runs the calculator, then he runs the music player, then he runs the movie. So in the music one, the next thing is movie. But for movie, the previous thing is music. For music, the previous thing is calculator. But
Okay, got it.
for calculator, the next thing is music.
Got it. Got it.
Okay. Okay. So task struct. This is task struct.
Okay.
Okay. And when no process is running in the system, this is the thing. So next is pointing to this, previous is again pointing to this. So it will show no application is running in the system. That is this. Thread and needle. So there is nothing like needle in this. So instead of needle, there is threads and processes. So okay, let's just complete this one. So thread is the unit of execution of object activity within process. So let's just talk about that summing of numbers. So this is a and b. So this is again a big number. Then another big number is this. So we just gave the whole number into this and this. So basically, if you entered this 164-bit number, it's split it into two threads, and this one again also split it to two threads. So these two threads will go and execute. These two threads will again go and execute. So thread is unit of execution और ऑब्जेक्ट ऑफ एक्टिविटी विद इन प्रोसेस. सो एक प्रोसेस पूरी ये थी, ये कैलकुलेटर ऐप थी. इसके अंदर के जो सब पार्ट्स हैं उनको थ्रेड्स कहते हैं. सिंपल, बहुत सिंपल. बट इन केस दिस इज कैलकुलेटर वन and this in another case this is calculator 2 again with a and b. So this is process 1, this one is process 2. Okay. So unit of execution within process is called thread. So the number distributed in two parts, that is being called in a thread. Okay. So thread is simply a new process that happens to share the same address. Space is parent. So basically, that's like understandable already. Like if we are creating a new calculator app, then all the variables, all the number that user is entering goes into the calculator one only and not calculator two. Let's just suppose if you are using Chrome and you are searching on Amazon also. So if you just try laptop, and if you searched on for laptop in Amazon, then the Amazon should not give the laptop thing or laptop word to the Chrome. Let's just suppose that you are opening a laptop in that Amazon and suddenly Chrome opens with laptop search, like laptop suggestions. That is not what you want. So that's why we want is all the things that we are finding should stay in one process. So if you are searching Amazon, like laptop in Amazon, then it should stay in Amazon app only. If you're searching something else in Chrome, then it should stay in Chrome only. So if you are downloading Akash papers via Chrome, then it should not download it from Amazon because you have never searched or never typed that thing in there. So the two processes are here in are Amazon and Chrome, and the number of things that we are doing in that is threads. Okay, I guess it's done.
Yeah.
So yeah, so thread is simply a new process that is sharing the same address as its parent. So जो parent का address होगा वही thread का address होगा. बाकी तीन चीज़ होती हैं, fork, execute and clone. तो process या तो नहीं create होगी, then process execute होगी, and then चलती हुई process is cloned. So one calculator is running, we run a new calculator. So two calculators are running. So it can be called as cloning of process. Then process termination. So every process ends when system calls exit. So basically, if you click exit button two times, it will call exit of that process and the process will be closed. Okay. And there is like one thing there also, the process will automatically get terminated if some error comes to that process. So the system will already automatically terminate that program. So finally, let's sum it up: threads and processes. So processes is the main thing, and the subset of process is called threads. There is termination of process when we call exit, or the something error or something wrong goes with that process. So yeah, that's enough for process. So we create a new process, then it gets into ready state, the process gets ready and it started to work, and then after ready state it went to running and it runs. Then if we pause that app, then again it goes to ready state and then again running and ready state and running. So this will go into a loop. Sometimes after running, we just make it stop, like stop until I ask you something else. So it goes into the waiting state, and then after waiting state, it again goes to ready state. And if someone is not using that app, then it can directly goes to terminate step. Terminate step. So these are the states of processes. So just mark these all: new, then ready, running, waiting, and terminated. That is important. New is when the new process is created, ready when it is about to start, running when it is running. If we are running any other application, then it goes to waiting. If you want to exit it, it goes to terminated. Okay. So yeah, that's it. So CPU register, then cache L1, L2, RAM, physical RAM and virtual memory, and then storage type, storage devices, removable drive, network, internet storage, hard drive, then input sources, mouse, keyboard, removable media, camera, remote source, and others. So you can just take a screenshot of it if you want. And that's like, let's just end this class on this note.
Done for the day.
Yeah.
Done for the day.
Any doubt?